one thing that we can do to help out with the collision so that we don't have to make objects go away per se as much as we can just render them no longer valid is we can attach a property to our obstacles that we're running into. And we can give them a property of busy. And we will assign to busy a value of true or false. So it has two possible states. So we can't have something be both true and false. It's either going to be true or it's going to be false. So in the beginning, when our game starts, the obstacles will not be busy because they won't be doing whatever they're doing. They're waiting for something to happen. So therefore, our objects are not busy. So busy is false. But what we can do is when a collision occurs, so when a collision occurs, we can set an obstacle to being busy. So we can say, hey, you're now busy. And that doesn't do us a lot of good. We can set it true, we can set it false until the cows come home or the bugs overrun the world. But it doesn't do anything unless we also then evaluate that at some point. So what we can do is we can also say, when I run into this object, and the double ampersand says and, so and if that object is not busy, so busy is equal to false, so we're asking, double equal sign is asking, a single equal sign then assigns or sets a value. So compare, set. So when the bug is run into the obstacle, and when that obstacle is not busy, then we will make that busy equal to true. So once I hit this obstacle, even though I'm still touching it, I will no longer be affected by it, because once busy becomes true, the next time I try and run this, busy is true, so then we don't do what's in here because now that's not a true statement. So now we can test it. When I go over here, I'll run, I lose 3, and now all day long, busy is now stopped. So what we will explore later on this evening is using a timer. So then with a timer, we will be able to then make busy become false again, so then I can run into this and be affected by it once more. So we will set a timer off, so maybe after 3 seconds, it becomes dangerous again. Working with the music in Flash is as simple as importing the music, so importing the sound directly into the program. So these files, file, import, doesn't matter for audio, but just choose import to library, that'd be a good option. And then that allows you to choose the sound, bring it in. Remember, CD quality or less. WAV, AIFF, or MP3 is preferred. If you have better than CD quality, Flash will give you an error message, so you need to downgrade it at that point. When you bring the audio in, you will notice that there is a column here in the properties for that called AS linkage, actionscript linkage. And we need to populate that with something so that we're able to then call instances of this audio into our project. So we do that, either you can just double click and type right there, or on your sound you can go and choose properties, and then when the properties comes up, you click on the ActionScript tab, and then you will check export for ActionScript, and then you will type in class name. That's a lot of steps. I think it's easiest, go to the AS linkage column, double click, type in a name. By convention, the name will start with a capital letter. The name will also need to have 0 spaces in it. Letters, numbers, and underscore are the only allowed characters, must begin with a letter. So the same kinds of naming schemes that we've had before. Camel casing is the preferred default for your naming scheme. So once you have imported your sounds into your library, you have set up the ActionScript linkage for it, then what we can do is we can now bring that audio into our project. So we do that inside our actions. And with that, we can now, oh, I went down too low. It's a good idea you keep all your variables up at the top so you have access, you know where they are all created. If you reference a variable in something, but the variable shows up on the next line, then you will get an error message. So you always have to put the variable in memory first. So what I can do with my variable here for the name, and I like to follow the name, I just wanted to see what it is again. So I will have hit sound. And now that is an object of type sound. And we will set it equal to a new. And this is where we reference that AS linkage name that we typed in. So a common convention is you make your variable name a lowercase version of your AS linkage name. That's the preferred method of doing so. And here where it says new, and then the word that follows after it, that must match exactly to your linkage column. So we can see my hit sound here matches hit sound with the same capital naming scheme. This is my lowercase version, and I will make my music one because I will need that shortly. So that now puts copies of those sounds into memory. If we wanted just to turn these loose in the wild and have no control over their volume, no control over their panning, no control over knowing when the sound is finished playing so we could play another copy of it, or to play a series of sounds in sequence, what we can do is we can then say something like hit sound.play, and we can just issue a command and just tell the sound to play. Now doing that will make the sound play, but as I said, we have no control over it. We can't change its volume, we can't change its panning, we can't find out when it's done playing. So if it's music, once we tell it to play, it's going to play until it's done. So if it's 5 minutes long, it will play for 5 minutes, even if we only wanted it to play for a short time window. So this is not going to be the preferred way, but it does work. So if I test the movie, the sound played once and that's it. I have no control over getting it to play again, so it's not really a good way to do it. So I'm going to get rid of that. The better way to do it is to set up an object called a sound channel. So I'm going to make an object, and it will be a sound channel, and we'll say it's a new sound channel. Now I just lost my sound. There we go. I always like to let the code hinting help to make sure I type things or capitalize them correctly. So we've created a sound channel object. Think of the sound channel as that is my music player. That would be my iPod, that would be my CD player. That's the thing that plays the music. And then the music itself that I'm playing are these sounds that I have now created variables for. And the correct way to get the sound channel to play is we can say music sound channel, and we set it equal to what we want to play. Whoop, that's not right. Music.play. So we set the sound channel equal to the sound we want to play, and we tell it to play. The advantage of doing this is we are now able to, with the sound channel, listen for when the sound is done. We can even pause the sound and resume playing at that exact point. We can change the volume of it through a sound transform. We can pan the sound. So we have a lot more options available if we use the sound channel object. So for what is really just one more line of code, it now gives us infinitely more flexibility. And you can have any number of sound channels in your project, so you're not limited to just one sound channel. So I like to set it up that I have a sound channel for my music and then have a sound channel where I play my sound effects. That way I can issue commands separately and know that one isn't going to override the other. So we will set that up in just a moment here. So now the music works, and what would be nice is to be able to listen for when this sound is done playing so we can loop it over. Now this music song is too long just to immediately go, so I'm going to change the sound so we can demonstrate the looping and use the hit sound with it for now. So what we can do with that, if we want to know when a song or sound is done, is once the sound is playing, then we can tell our sound channel object to listen, and the code completion, we will notice, gives us activate, deactivate, and sound complete. The thing we want is sound complete. We want to know when that sound is complete, when it's done playing. So I can click on that. So when that sound is done playing, we'll have it call a function called repeat music. Now this function, we can just write it out. I want to move this. It's not an ideal location in my code at the moment, but this allows me to keep it on screen all in one place. So we named the function, we referenced the event that called it. It was an event, so we have our function reference, and then we have the type of event that was referenced. And now, if we want the sound to repeat, then what we can do is just repeat that line right here. So we can tell the sound to play. And now if we listen to it, so it should repeat now the hit sound. And what we'll notice is it played exactly 2 times. So what's happening is the sound plays. I'm going to put this up here and that down there. Then the sound starts listening for being done, and it runs this function, and that function says play the sound. But once the sound is done, we have to also tell it to re-listen for being done. So we have to create this perpetual loop. Now, it's getting really obnoxious because it's playing that awful sound. But if this, instead of our hit sound, was our music. So if we're telling the music to repeat, now when the music gets to the end, and the music itself is going to be, we'll never hear the end because it's 3 minutes and 43 seconds long, so we'd have to listen through that to hear it repeat. So that's why we demonstrated it with the hit sound, but we know that it will now work, and it will play the music. So now our game music will run indefinitely and just keep looping no matter how long it takes the player to get through the project. So now we have the game just looping. Now there's other things you could do where you could now stop this music and you could now play other music based on other events in your project. So you can tell the sound channel to stop and then tell the sound channel to be equal to a different sound and tell that sound to play. So we have the ability just to keep extending this out, so you could keep changing the sound in your project. Or you could decide one background music track is more than enough and that's all you want, and that's cool. Just make sure it's more than 30 seconds long, otherwise the looping will get really obnoxious. If it's 3, 4, 5 minutes long, at that point when it's looping, we really aren't going to notice because we'll probably, after 2 times through, be done with the project anyway. So then that would be a good way to work. Adding in the sound channel for the sound effects is really going to be my, I'll have an effects sound channel. And then we can tell that the effects sound channel to play our hit sound when a collision occurs. So if we go, once that's in place, then it's just a matter of under that collision, if we collide, then all I have to do is say my effects sound channel is going to be equal to my hit sound dot play. Now we don't need to put an event listener about, hey, how are you done playing or anything, because this is typically sound effects or sounds we just tell them to play. We just want them to go. And technically I could do it without a sound channel object here because I'm just wanting that sound to play, but this would be considered a better way to go about it. So now when I collide with that object, then it's going to play this sound. And we will see then it will only do it the first time because it's tied to the busy statement, since we still have that busy going on. So if I run it, got some music, and now I can go through. So it works. If I want that sound to play on my other object when I collide with that, I can put that on my second object down here. So hit test object obstacle 2. Go stick that in. So now I have a sound for and we will notice that it played multiple copies of that sound when I hit that second object. I'll repeat it again here. Now when I hit the second one, as I'm going through it, you can see as long as I was touching it, it kept playing that sound because our second obstacle, we haven't put in the busy part of it. So we did not say and obstacle 2.busy is equal to false because we didn't specify that or make it become true the next time. If we do change that, it will now play that sound only one time. And then we don't get that lingering sound that continues on through the game. So that would be a method for dealing with sounds and getting the sounds to play within the project. Now the next stage is to add in our timers, and then working with the timer object we can then set up so that we can fire off a timer when I collide with, say, the first object that then makes it's busy false, but then after a certain amount of time that object's busy becomes, it makes the busy true, but then once that timer is done, the object is no longer busy, so then I can collide with it again. So that's what we add in next. So in the timer file, there's a text field here. This text field needs to exhibit two properties in it. It needs to have an instance name, and it needs, well, I guess three things: instance name, classic text, and dynamic text. Classic versus TLF text. We're not going to touch TLF text in here, so just don't go there. Dynamic text, so that it indicates it can be changing content. We're giving it the instance name of clock field so we can access it through code. Now this particular text field, you can see I chose a fantastic, wonderful, awesome font called Comic Sans because I can. Now, one thing when we use fonts, especially in dynamically generated text fields, we need to embed the font characters into our library. So I embedded the font into this CS here font right there. Now that particular embedding happens by clicking on the embed button. You can type in a name if you want, then you choose what parts of the font you wish to embed. I embedded uppercase, lowercase, numbers, and punctuation. If I don't do that, so if I don't put the numbers in, or if I don't put in my uppercase letters, and then when I run this, currently the only font outlines If I didn't have any of that checked, the only font outlines that would be included would be JUNK. So I intentionally typed in letters that don't mean anything, just so I can see what font and what color and what size the text will be in my text field. Now if I run this, it launches and we can see I did not embed capital letters and I did not embed numbers. Therefore, I only get to see lowercase letters and symbols such as the colon, or after 10 seconds also the exclamation mark. So we have to embed the correct outlines. So when I go back to embed, let's get our uppercase and numbers. So you do need to do this. If you fail to embed any of it and run it, we can see nothing shows up. But also the first time you do that, I think I already checked under the box that says you need to embed your text, unless you need the font outlines, blah, 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 all kinds of stuff. You're like, whoa, what? Oh, yeah. Embed your font. So click embed. Choose uppercase, lowercase, numbers, punctuation. If you're only doing numbers, you could choose just numbers, but invariably you will select just numbers, then decide to send a word to this text field as well down the road and wonder why it's not showing up and you think your code is broken and your code is fine. You just forgot to embed the font outlines. So embed the font. There's my font. It will now export with my project. And now we can see it gives me the text field, populates it with the word, the symbol, and the numbers. And then it counts down from 10. So dynamic text fields. Classic text, give it an instance name. The instance name here is clock text. Now when I look at the code that's going on here, there's a few important things that are going on. We can forget the imports. It wrote those lines for me. But what I do have happening as part of this is I have my variable, my timer object. Timer objects have a delay, how frequently we want the time to fire, and then we have a repeat count, how many times I want the timer to run. So my timer is now going to run 10 times, and my delay is 1,000 milliseconds, or 1 second. So every second, this timer will tick off one more tick of its time until it's gone 10 times. That's how it works. When we have a timer object, we can listen for the timer event, the tick of the clock, which happens in this instance every second. And we can listen for the timer being done, which will happen after 10 seconds. And each one of those will call their respective functions. After we've set up those listeners, we tell our timer object to start. And then we also call our show clock function. And the show clock function populates that text field with the appropriate text. It sets the text property of it equal to time, colon, space. And then we have to convert this math equation of our repeat count, 10, minus whatever the current count is. Current count starts at 0. So that's why it's 10 minus 0 is 0. So therefore, the first time it shows up, it says time 10. The next time, current count is 1. Repeat count is still 10. That's how I get my 9. 8, 7, 6, 5, 4, 3, 2, 1, and then time's up. And then at 0, it fires off the timer complete. And it now gives me my clock end function where it changes the text in the field to done. When we want to call all of this that set up this, I can just call start clock, and that now starts my clock running. So this line fires off this line, which then gets my timer. Oh, whoops, hang on. I combined two things together and forgot we don't need that line anymore. Your sample that you have on paper does not have it. So your sample on paper looks like this. Does not have it. So fires off. So we create our clock variable. Tell it to listen for ticks, listen for being done. Tell it to start, update our text on screen. If we're just using the timer to control things and we're not going to show anything on screen, we don't need this show clock function. We don't need to deal with it. We can just fire off and tell the timer to start. So we can now take this code and integrate it with the movement project that you're working on. So then we could set a timer so that when we collide with an object, it becomes busy. And then when the timer is done, we can tell the object it's no longer busy, so I can run into that object again. So we can set it up so that objects reset themselves based on the timer. And that's where we're going to move to next. Adding the timer into the project now requires us to make a timer object and get that set up so that we have the timer object, and then we can call it to run when we need it to run. Again, it's a good idea to always have your variables at the beginning of your project. So now I am going to call this reset timer. I don't like that name, but we'll run with it for now. And it is a timer. Notice the code hinting helps you out. If you start with the word var, then you say the name of what you want, colon, and then when I hit that, now it's going to be much happier. And now when I type in my equals, now I can say new. And then when I hit timer, it comes up, can hit return, parenthesis, and now the code hinting is telling me the first number is going to be my delay in milliseconds, and the second number is going to be my repeat count, how many times I want this timer to fire. Well, right now I want this timer just to fire off and run for, in this case we'll do 2 seconds, and then it will be done. So at that point we can just say we can fire it off for 2000, 1, because we know it's just a one-off timer. Or if it's easier for you to think in terms of seconds, start out and just say 1000 milliseconds or 1 second, and then 2 second delay. So that now sets up my timer and gets it ready to go. Now what we can also do with this is we can now tell our timer to add listening. And again, the code hinting helps me so I don't have to memorize what I'm looking for here. But what I want is my timer event timer complete. So I don't care about the ticks of the timer in this regard. I'm just going to care about the timer being done. So I can arrow down, choose it, type it in, and then I now need to now I'll call a function reset obstacle. The next order of operation is going to be to make this timer start when the collision occurs, and then we need to have our reset obstacle function defined, which is where we will be able to then tell the obstacle to reset itself. My next step of operation is going to be to start the reset timer when I run into something that I need to figure out what to write for my reset obstacle. So going down to my conclusion, or my collision, so I'm going to just collapse my draw here, and collapse my health, don't need that. All right. So in my collision, currently, if I'm running into the first object here, well, we already messed with the first one, so I'm going to put this on the second object. So currently, when I hit the second object, it tells it to go to and stop to its crash frame. So what we can do at that point, we can tell reset timer to, and because Flash now knows what kind of object this is, once I typed reset timer dot, it's now giving me timer objects or timer methods, properties, everything. And the item I'm looking for is going to be start. So we tell the reset timer to start. So when I run into it, I'm going to tell the timer to start. So now that I told that timer to start, we need to define the function that will be called. And we need to now reference reset obstacle. And as part of this, it's going to be a timer event. And we know that it's going to be that because that is what was in, that's what type of event is calling this. So going back up here, we can see that my reset timer is listening for being done, and when it's done, it's going to call reset obstacle. And we can see that it is a timer event that is listening for this event. Therefore, I have to reference that inside my function definition. That's just part of creating functions in a typed language. The same way that my key press references the keyboard event, my frame items reference events. So we have a number of events that we're going on. Keyboard events, timer events, events, mouse events. All these things can be built into our project. So at this point, we could do any number of things. Right now, I'm going to tell my obstacle to go to and stop. And I don't remember if I gave it a label on its frame 1, but I know that frame 1 is its beginning frame. So I'm going to tell the object to reset itself. So after 2 seconds, the object is going to stop being on the crash frame and is going to go back to its original frame. So that's obstacle 2, go to and stop, and we tell it to go back to its first frame. So that's telling this object to reset itself. And if we're lucky, it'll work. It worked. It worked exactly as we coded it, because we've now told the object to go back to its first frame. But if we notice, we never changed its busy state, so we could never hit it again. And we may have some other things that we'll have to deal with as well. So we can tell obstacle 2 to set its busy back equal to false, so it's ready to be hit. And now we can see we're able to keep tearing through that object and get it to work. So by combining this busy concept with our objects, we're able to control them so they may only hurt us for a little while. And using a timer object, we're able to then get objects to be temporarily out of play or out of commission, and then we can reset them. Now, what we could do, if we don't make the object blow up, we could just simply make the object so that when I hit it, it's busy, and then when it's not, it resets itself. So we will hear the sound as part of that. The health, I'm going to modify my starting value so I can hit it more times and we can see changes occurring. So my health is down. I hit this the first time, it goes up. But but I'm on top of it, and it takes a while before my health goes. Oh.
If you just sit